In this video, we're going to be looking at how we can take the angle measurement within the sine or cosine function and treat it as the sum or difference of two other angles. So the title that we have here is Formulas for the Cosine of Alpha plus or minus Beta and the Sine of Alpha plus or minus Beta. So I have here all the different combinations that we could be looking at. We've got the sine of alpha plus beta, we got the sine of alpha minus beta, and then we've got the same two things for the cosine. Now, each of these are going to be equal to what I have here to the right. Okay, so the sine of alpha plus beta is going to be equivalent to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay, now what I really want to do at the very beginning here is an example of what you can't do. I'm going to start with what you cannot do. So take a look at the first one we have here, the sine of alpha plus beta. Suppose that we had two angles, alpha and beta, and just call them 40 and 60 degrees. Okay, so we got 40 and we got 60, and if I add those together, I get 100. So if I were to evaluate the sine of 100, I get that answer. Okay, but what I want to demonstrate right now is what you're not allowed to do. You cannot take that angle that you have in the middle and split it. You cannot write this. You can't do the sine of 40 plus the sine of 60. Okay, it looks like it might be a clever idea and something you could do, but you can't. You don't get the same answer back. It's completely different. However, this does work. Okay, now it's a lot larger than just breaking apart as I showed here, but it does work. If I take the sine of 40, so I'm going to let alpha be 40, take the sine of 40, multiply that by the cosine of 60, plus the cosine of 40 multiplied by the sine of 60, that does equal the sine of 100. All right, and the same thing is going to be true for the rest of these. You can't just take an angle measurement that you have inside, break it into an alpha and a beta, and then try and split that trig function using those two angles. You have to use these setups. You've got to use these. Now, we're not going to go through the process of proving these, but we're going to go ahead and start to apply them. So I've already demonstrated the first one. You could, on your own, choose an alpha and a beta. You could use the 40 and the 60, and you can test these out. So if you did 40 and 60 here, what you'd be looking at as a total inside would be negative 20. But then you could put the 40 and the 60 in each of these spots, and you can verify that these all actually work. Let's go ahead and take a look at a problem where you can apply these formulas. Example 1, find the exact value of the sine of 15. The exact value is what we want. The exact value is sine of 15. All right, now we're going to be able to do that because we know that 15 degrees is actually the difference of 45 and 30. It's the difference of 45 and 30. Okay, so if I treat the 45 as alpha and the 30 as beta, okay, then what I could do is take the sine of 15, and I can rewrite that as the sine of 45 minus 30. I think we can agree that that's the same thing. Okay, but I'm going to define the 45 as alpha and the 30 as beta, and when I do that, I can reference this. I can reference that setup. So this can be translated into that. We can take the sine of 45 multiplied by the cosine of 30 minus the cosine of 45 times the sine of 30. All right, and now all of these, what's special about this is that we're using the 45 degrees and the 30 degrees, right? A couple of these special angles that we know how to evaluate within these functions. So the sine of 45 is the same thing as the square root of 2 divided by 2. The cosine of 30 is equivalent to the square root of 3 over 2. Cosine of 45 is also square root of 2 over 2. The sine of 30 is equal to 1/2. All right, and then if we multiply these together, square root 2 times square root 3 gives you square root 6. 2 times 2 is going to give you 4. Over here, you're also going to get a 4 as a denominator. And the square root of 2 times 1 is square root 2. All right, so all together, you can actually simplify it this way. You can do the square root of 6 minus the square root of 2 over 4. You can do that. All right, now these you can't actually group. Can't do anything with those. Multiplication, you can multiply the radicands. That would be the numbers inside the radicals, but you can't actually do anything with subtracting. All right, so this is going to be our answer, and this will be our exact answer. Now let's go ahead and verify it in the calculator just to see that it works. All right, so the whole thing begins with the sine of 15. All right, so sine 15 is equal to that, and my claim is this will also give that value. All right, and there we go. We get the exact same value. Example 2 is a bit of a silly problem because you've got this massive expression that you might not normally come to in a problem. But what we're trying to get at here is working backwards. Okay, so this is going to match one of the formulas that we have above. The 50 degrees could be treated like an alpha, and you can see it here. You're also going to see there. The 10 degrees you can treat as the beta that you see in these two spots. Okay, so what we have is a product of the cosines with alpha and beta, and then we're subtracting the product of the sines with alpha and beta. All right, so that is going to match up to this, the product of the cosines subtracting the product of these sines, okay, with alpha being 50 and beta being 10. What that means is we can change it into this. Okay, we can change this problem into the cosine of 50 plus 10. We can change it into cosine of 50 plus 10, which is the cosine of 60. And of course, the cosine of 60 is equal to 1/2. Example 3, suppose that the sine of alpha is equal to 4/5, the sine of beta is equal to 5/13, and alpha is going to sit between 0 and pi over 2. That would mean that alpha is a quadrant 1 angle, and that beta sits between pi over 2 and pi. That means that beta is a second quadrant angle. What we want to do is find the cosine of alpha plus beta. For that, what I'm going to do is reference the equations that we've got, and here is the cosine of alpha plus beta. That would be equal to the product of the cosines minus the product of the sines. All right, let me go ahead and jot that down. That would be cosine alpha times cosine beta minus sine alpha times sine beta. Let's go back to this part here. The sine of alpha is equal to 4/5. That might remind you of the definition of sine, which was the y value divided by the r. So what I'm going to do is draw a picture of a circle that can represent those numbers. Remember that alpha is going to be a quadrant 1 angle. Okay, now I'm not going to worry about exactly how it's positioned. I'm just going to draw it out here in quadrant 1. Okay, and we're told that the sine of alpha is 4/5. Based on the definition, 4/5, the 4 would be the y value. That would be here, and the 5 would be the radius. And this is a right triangle. So you could probably go ahead and figure out that the x that would correspond to these values would be a 3. That is a Pythagorean triple. All right, likewise, beta is going to be located in quadrant 2. All right, so let's get beta out here. Again, just going to draw it out there, not worry about where exactly it is. The y value is going to be the 5, and the radius is the 13. Okay, so this is 13. This would be a 5. And of course, this is a Pythagorean triple as well. This length here would be 12. It would actually be 12. However, this is in quadrant 2, which means that that is not really 12. It is actually negative 12. It is a negative. These will all be positive in quadrant 1, but in quadrant 2, you're going to have a negative x value. All right, so let's go back to this part here. The cosine of alpha, sort of like how we saw the sine of alpha, we can present that as a fraction. Okay, but by definition, it's going to be the x divided by the radius. In that picture, that would be 3/5. So we get 3/5. The cosine of beta, I'm going to take that from the second picture. So that one's beta. This was alpha. All right, from beta, you're going to have negative 12/13. All right, and then we'll be subtracting the sine of alpha. We had that one. That's a freebie. That's 4/5. And even the sine of beta. That is a freebie as well. You got 5/13. All right, so let's just do some math. Look at the two fractions. They both have a 5 and a 13 in the denominators. That means, so 5 times 13, that means that overall, we could just have a common denominator of 65, 5 times 13. All right, for the top, that will be negative 36. This would be a 20, but we're minusing 20. So that means that our answer can be simplified as negative 56, as negative 56/65.
Later, blah.